there's a lot of different plastics you can make, but 75% of the plastics are what's called the Big Six plastics. Okay, 75%. And so what I want you to do is take a close look at this table and read down the properties of the polymers that are made from these monomers. We've looked at ethylene, vinyl chloride, styrene. Here's polypropylene. The monomer unit has the methyl group on it, so it's got 3 carbons. That's why it's called propylene. The systematic name would be propene, but the common name is propylene. And you can also see here the recycling symbol for each one of these. And the recycling symbol indicates how much that particular plastic is recycled. HDPE is number 2. That means it's the second most recycled plastic. That's what the number indicates. And then the abbreviation under the number tells us what type of plastic it is. That's how I knew that one plastic container in the previous lecture was HDPE, because it said HDPE under the recycle symbol on the bottom of it. Anyway, this table gives the properties of the polymer and the uses of the polymers. So rather than me read it to you, I want you to carefully go through it. The first 5 in this table are all addition polymers. This one, polyethylene terephthalate, is a condensation polymer. So we'll look at that in the next lecture. But before we get to that, what I'd like for you to do is study this table, look at the different properties for the different plastics. One plastic that we didn't talk about, but you should definitely read about, is polystyrene. Polystyrene, like styrofoam cups, styrofoam coolers, whatnot, are made out of polystyrene. And you can get like the little like cocktail plastic glasses. They're kind of clear, rigid plastic, are also polystyrene. And those vary between like styrofoam and the clear plastic polystyrene that's sort of brittle, based on how the polymer is molded. If it's molded in the presence of a gas or a small volatile organic compound, you get little air holes as the plastic cools. So you heat it up and shoot it into a mold with this gas or a small molecule that then evaporates very quickly upon cooling, and you get little holes, and that's how you get the styrofoam. Or if you mold it a different way without the extra agents, a gas or the volatile organic molecule, you just get a real brittle, clear plastic. So anyway, you should read about all of these because it's pretty interesting. And then after you do it, I want you to answer these questions to help you take a close look at the table and guide your discovery of that table. The only question that you might have a little bit of problem with is question A, and that says which polymer from the previous table would be suitable for margarine tubs because it softens with oil. It's not real obvious, but it's probably the polystyrene because they dissolve in many organic solvents. So it'll probably soften with oil because oil is hydrophobic like the organic solvents. The rest of them you should be able to answer in your small groups. Just a way to check yourself and spend a little time with this table